Now, my dear student, from equation 4.29, at the moment of inertia of the small disk of mass 1, mass 2, and also mass 3 are located at a distance r from the center of the disk is given by I1 is equal to my r square, comma, I2 equals to m2 r square, and also I3 equals to m3 r square. This is how we can obtain the moment of inertia for the moment of inertia for the small disk that are found inside the cylinder. So if we would be asked to find the moment of inertia for this disk number 1, it should be I1 equals to m1, then we multiply it by r square. While the moment of inertia for the disk 2, the second disk, must be represented by I2, which is equal to m2 r square. And for the disk 3, the moment of inertia for the disk for the third disk must be equals to m3 times the r square. This is how we can find the moment of inertia. So after this one, my dear student, the total moment of inertia of the solid cylinder about an axis PQ through its center is the sum of the moment of inertia of such small disk for the whole solid sphere. So how can we get the total moment of inertia of the solid sphere, of the solid cylinder? The moment of inertia for the total moment of inertia for the whole or the for the solid sphere, it can be obtained by summing all of those moment of inertia that are found for each disk. It means we should obtain the moment of inertia for the total moment of inertia for the solid cylinder equals to the moment of inertia 1 that we tried to see, plus the moment of inertia 2 that we have tried to see, and plus the moment of inertia 3. But we know their meaning, that how can it be expressed? Now, if we omit the I2 by substituting its formula, now we should say that the moment of the total moment of inertia for the solid sphere must be equal, for the solid cylinder must be equals to half mi r square. Then we add it by a half m r square m2. It means this is for the second disk. Then we add it by half m3 r power 3. Then we add it by dash plus a half mn r square. This should be our fourth equation. Kwa hiyo hapa ndio itakuwa ni equation yetu ya tatu ya kutafuta ile moment of inertia. So after this one, my dear student, what we are going to see. So baada ya kuona sasa formula ya kutafuta moment of inertia ya the solid sphere, now we are going to go and demonstrate that if we have that, let us imagine that the disk that are found inside the cylinder must contain the same masses ambayo itakuwa ni individual masses. Now it can be written at this one. So instead of writing m1 r1 r square, we add m2 r square, we add m3 r square, then we add dash n times of the mass times r square. We should put together because the radius and the half are the same. Now we are supposed to factor it out. Kwa tukisha factor out, tutapata sasa kumbe moment of inertia badala ya kuandika m1, m2, m3 mpaka mn hapa, tutaandika ni sawa na m kubwa. If we express instead of this one, it should be equals to the individual masses. Now this should be the moment of inertia should be equals to a half m r square, and this will be our equation number 43 for our fourth topic, where this m1, m2, m3 that plus plus dash the instance of the instance of the mass of the disks. Now should be equals to the larger m. It means should be equals to m kubwa kama tunavyojaribu kuiobserve hapa. So after this one, my dear student, what we are supposed to do? So which is the mass of the solid cylinder? Therefore, the total mass of the inertia of the cylinder about an axis through the center, it is given by this one. Kwa badala sasa ya kufactor out wale common ambao ni a half r square, baada ya kufactor out pale tukaleti kuwa huyo m1 plus m2 plus m3 plus dash dash plus mn equals to m kubwa. Now we should say that we should express equals to the larger m as we see here. Now we should conclude by saying that therefore where this m, the larger m, represent the mass of the solid sphere, and I represent the total mass of the solid cylinder. This should be the total mass of the solid cylinder about an axis through its center. Now, my lovely student, after this one, we should conclude by saying that the total moment of inertia for the solid sphere is given by half mr square, where I represent the total moment of inertia, while m represent the total mass. It means the mass of the solid cylinder, while r square, r represent the radius of the hollow cylinder. This is how we can demonstrate the formula of the moment of inertia for the solid sphere. Remember, we are supposed to note that we should assume that inside the solid sphere we have several disks that they are being rotated about an axis. It means on an axis. They are rotating on the axis through the center. So after this one, my dear student, now the key point to note is that the formula of the moment of inertia of the solid cylinder about an axis through its center is equation number 1. The equation number 44, this equation here, this equation should represent the formula of the moment of inertia for the solid cylinder. This should represent the moment of inertia for the solid cylinder, my dear students. And after this one, now we should say that this formula of the moment of inertia for the solid sphere must be equals to the moment of inertia of the disk. Kwamba hii formula ya hapa inafanana ile ya kwenye disk, kwa sababu kwenye disk tulidemonstrate ambayo ilikuwa ni question number 29 for our first topic, tulipata ni sawa na half mr square, na hapa tumejaribu kudemonstrate ya solid sphere tumepata ni sawa na half mr square. Kwa hiyo kitu ambacho tukiconclude pale kwamba formula ya kutafuta moment of inertia ya solid cylinder ni sawa na formula ya kutafuta moment of inertia ya ile cylinder. It means ya hii sphere. So by saying that, my dear student, there are some tasks here you should be asked. One of the tasks is that can you derive the moment the formula of obtain the moment of inertia for a solid sphere, or prove that the moment of inertia of a solid sphere is equal to half mr square. That is the task that you should be asked, my dear students. And after there, you should be asked the second task is that find the moment of inertia for the solid sphere if it contains the mass equals to 20 kg and their distance or their radius is equals to 5 meter square, equals to 5. So you should demonstrate, you should answer those two tasks, and after there you'll be competent on the moment on the solid cylinder. So by saying that, my dear student, this is the end of our session here. Now I would like to invite you again for another session. I wish you all the best. Have a nice moment.